All right, so day 2 of P-5. So today we're going to talk about domain. Domain is what values? X values. So we're specifically referring to what affects X values. So what kind of things will restrict an X value? We already talked about one of them today when we were going over homework, right? What are some things? Holes in, caused by the denominator. So denominators. So your denominators will create a restriction to your domain. In other words, they cannot equal 0. So that's one thing. Then there's a second thing. Well, look at the problems here. Which one of those has restrictions where you can't have a particular number there? Out of those 4. The second one, well, that's your denominators, right? What about the third and fourth one? What kind of numbers can you not take the square root of? Negative numbers. So if we're looking at, and I'm going to say for our purposes, even roots, right? Because we could have a fourth root. Can you take the fourth root of a negative number? Is there any negative number that you multiply it by itself 4 times? Well, right. Well, you could use I, but we're going to assume that we can't use I because we're in the regular coordinate form. So any even roots or you might call them radicals. They must be greater than or equal to 0. So those are the domain restrictions that we are going to apply. So what is the domain of this? And you can actually look at it on your calculator also. But what's the domain of this? And for those of you who don't have a calculator, I'm going to plug it in and show it to you. Are there any denominators where there's a variable? Yes or no? No. Are there any radicals? No. So do you think there's any restrictions? If there's no restrictions, then what do you think the domain is going to be? Could it be any number you can think of? Can I put any number in there and come out with a real number? Yeah. So how do I describe any number I can think of? All real numbers. So very good. So if I put in for y equals 3x squared plus 4x. Oh, I'm on the wrong graph. Come back to me. Now look at it. Do you see that as this parabola, because it's a quadratic so it makes sense, it's a parabola, as I go across the x-axis, won't that parabola just get wider and wider and wider? Won't it eventually cover the entire x-axis? Mm-hmm. It'll never run out of x numbers that I could plug into there. So there are no restrictions. So it would be all real numbers. How do you think our interval notation would be for all real numbers? What's the left bound for all real numbers? Negative infinity. What's the right bound? Positive infinity. So because infinity has parentheses, it does look like an ordered pair, negative infinity to positive infinity. All right, so then next one. What might cause a restriction here? Yeah, so x plus 3 cannot equal 0, right? So if I actually solved, and these are your notes, many of you are beyond this, right? X cannot equal negative 3. That is the only restriction. X can be anything but -3. What's the left bound to that? Negative infinity. Then we hit what number that we can't have? -3. Do I have a bracket or an open circle there? If it's not part of the solution. Parentheses. Then, because I'm showing a hole in my graph, I essentially have the entire x-axis but -3. I do have to do my union. And then my left bound for my next side is still -3, but it's an open, parentheses again. And then its right bound is positive infinity. So that's how you show one number hole in the graph with your interval notation. And then this particular one, if I plug into y equals, I'm going to put 1 divided by parentheses x plus 3 and parentheses, and then hit graph. Do you see how it's covering the entire x-axis except most of your calculators will not show the asymptote. We have a vertical asymptote going right through what number? -3. And if I go to my table of values and I put in -3, what comes out? Can't have it, right? But I can put in any other number I want to and it'll still work. So again, that's showing that I'm going from negative infinity to -3, but not including it, and then -3 to positive infinity, just not including that -3 again. Not so bad, right? All right, next one. What's the restriction on this one? Well, what about this? What does that have to be equal to? Positive numbers or 0. So we're going to take that x plus 5 and we're going to set it greater than or equal to 0. And I want you to show that in your notes, because what if I gave you something more complicated than x plus 5? So when we go and solve for this, we get x is greater than or equal to -5. We'll talk about the interval notation here in a minute, but let's look at the graph of that. So I'm going to go to y equals, clear that out, and I'm going to put in the square root of x plus 5, and then hit my graph. Isn't it covering the y-axis or the x-axis from here to positive infinity? Where does it start at? -5. And so that's exactly what this is saying. X has to be greater than or equal to -5. So what's my left bound point? -5, is that included in the solution?
Yes.
Yes, so bracket. What's my right bound? Positive infinity. So open parentheses. And then the last one you should be able to do on your own. But with an x squared in there, what do you anticipate? You should have two answers. So 64 minus x squared, what are you going to set it to? Greater than or equal to 0. So when I subtract 64, I have a negative x squared greater than or equal to negative 64. Can I take the square root of both sides the way it is? Mm-hmm. No. So I have to divide by a -1 or multiply. When I multiply or divide across the inequality, what do I have to remember to do with that inequality sign? Flip it. So I've got x squared is less than or equal to positive 64. So now when I take the square root of both sides, plus or minus the square root of 64, I end up with x is less than or equal to positive or negative 8. At this point, my inequality sign means nothing to me. What does mean something to me is the fact that I have two critical values. What are they? Yeah, 8 and negative 8. So I have 0 in between, 8 and negative 8. So that creates my 3 sections of the graph that I'm going to checkpoint. So I'm going to check negative 10, because that's one of our favorites. I'm going to check 0, and I'm going to check positive 10, up in the original problem. So if I check negative 10, what's negative 10 squared? 100. What's 64 minus 100? What kind of number is that going to give me?
Negative.
A negative. Can I take the square root of that? No. So this is going to be false down here. So that's not part of my graph. What are you going to choose in between negative 8 and 8? 0. So 0 squared is 0. 64 minus 0 is 64. What's the square root of 64? 8. That works, right? So this gives us a valid answer. It's true. What happens if I choose 10? When I run into the same situation, 10 squared is also 100. 64 minus 100 is still going to give us a negative answer, which I cannot take the square root of, so that's going to give me a false thing. So what does my interval notation look like? Well, first of all, algebraically, it's going to look like x in the middle is less than or equal to 8. And then if you read it backwards, x is greater than or equal to negative 8. You could write them separately if you chose. So that's your inequality answer. But looking at this graph, I would have a closed circle at 8, negative 8, a closed circle at positive 8, and a line in between. What does your interval notation look like?
Bracket, negative 8, comma 8.
Yeah, bracket negative 8, comma 8, bracket. That's all you're doing for your domain. And then on this one, let's just look to see what it looks like. So we're going to put that into y equals Now it does look like it's not touching on my calculator here or here, doesn't it? So if you're not sure, where could I make sure so I can see if negative 8 and 8 are solutions? What could I do on my calculator? I could change the window. I could go to my table. Okay? So go to your table, and I'm going to plug in 8 and negative 8. What answers did I get? So doesn't it touch the x-axis there? Sometimes your calculator doesn't show it. So if you're not sure, go to your table and check it. So it does go all the way down here. So this is my domain right here, from here to here. It only includes those values, nothing outside of it. So you can physically see the left bound and the right bound parts of your domain. Okay, any questions on that?